startup, you're supposed to run through a fuse check. There's a 2-bit register. One bit tells whether or not you've attempted a fuse check. The other one tells whether or not that fuse check was successful. When you voltage glitch, they sometimes jump around. And when they jump around, the rest of the JTAG state is also knocked out. But you don't care because the JTAG state machine is designed to be recoverable. From any point in that state that's valid, you can navigate back to the beginning. So here, instead of performing the entry sequence, glitching, and then seeing if it was successful moving back to the beginning, you could actually glitch, see if you wound up anywhere, if so, move back to the beginning, and then test to see if it works. So even if you wind up damaging every single register's value in the chip, except for a couple of toggles that knock things out of whack, it'll let you through. On some models of this chip, if you try to debug them without a decoupling capacitor, they'll fall in accidentally using the official debugger. Here's the fuse check sequence. It's the same as the other, except that on the set TCLK line, the second one that's noted, at that point, you're not allowed to debug the chip, but you are in the state machine. It's only after the second one that you're allowed to move forward. If it denies you, it just forwards all traffic to the next chip. Running low on time, so I'll skip through ISP debugging, except to point out that it's very similar to the previous chips, except that it really has a lot of awkward bytes that can come out of sequence or out of order. And a good way to get around that is to actually graph what the thresholds are. So if I have this chip and I'm lowering the voltage on it, at what voltage does it fail? If I look this up in the data sheet, they give me a single threshold. That's not what it looks like. This is what it looks like. This is the probability that I can successfully read the model number from an unlocked chip. Why is there this local minima? Why is there a local maxima next to it? What else does this correlate, and how does this affect the low voltage that I need for glitching? Because I've been choosing these at random prior to this. I've been working on getting that to work at the same time that I've been testing these devices to ensure that I don't break any features as I add new ones. Because you've got lots of incestuous C code. You have functions calling functions that they weren't designed to. The JTAG 430 module calls code for the JTAG module. So what you can do is you can set up a regression test server, and you can just graph everything. And this is really cool because you can do things like graph the stability of chips in the face of multiple failure modes. I'm controlling the voltage and graphing the probability of success of trying an action for 4 different actions here. And I can get this graph with 10,000 samples on each, and it all happens in Philadelphia while I'm out here having fun in Berlin. And with enough samples, if I want to extend this out on another axis, if I'll wait for a month, I can get this in 3D, with the third axis being the time at which it glitches. Then, once this new graph is complete, what I expect to see is a line right here, looking like a mountain on the 3D graph, where like the depth dimension is time, that shows me exactly where it's most likely to glitch. And if I find this correlation, that will then mean that you can go from the cheap, easy-to-generate graph to the complicated one that tells you how to actually get into the chip in like an automated fashion. You can measure the simple thing and use that to figure out where the complicated thing happens, or the rare event happens. And then you don't have to wait overnight for the chip to be glitched into, as the AVRs sometimes take. You can just do it in a couple of minutes. So anyways, there's a bunch of other crap here that I don't have time for. But do catch Felix Domke's talk on day 4 in Sol 1 at 1400. His paper is interesting. And if you'd care to help, I've got all sorts of stuff to do. The other thing is that I have free GoodFET boards. I was supposed to have them here. I don't. I'll mail them to you. They are free, but I do like Clubmata and PayPal. You can grab my articles on travisgoodspeed.blogspot.com. That's my email address. And glitching itself is not my idea. It's been done by satellite TV hackers forever. I'm just commoditizing it without the whole fraud aspect. So thank you kindly. I hope you enjoyed yourselves. Is there time? Yes. We have 4 minutes for questions. Come up to the microphones and be quick about it. Just start talking. Don't wait to be acknowledged. Okay. Well, have fun.